Hi there. Let's review what we've learned so far about pressure by calculating the pressure of this column of water. Then let's get into understanding hydraulics and how they differ from pneumatics. So here's our column of water. This time we'll notice that the dimensions are in meters. So step one, let's get the volume of the water. And then once we know that, we can convert it into mass. To get the volume, we need to make these into centimeters because 1 gram is equal to 1 centimeter cubed of water. And so we have to make these into centimeters. So 0.5 meters, that's 50 centimeters. And this is 20 centimeters. And this is 100. So the volume is 50 times 20, which is 10 with 2 zeros, times 100, which is another 2 zeros. So we need 5 zeros. 1, 2, 3, 4, 5. So 100,000 centimeters cubed. So what does that mean then about the mass? The mass is also 100,000 grams. And now we can convert it to weight. So 100,000 grams is the same as saying 100 kilograms. And on Earth, 1 kilogram is equal to 10 newtons. So this is 1,000 newtons of force. Now we need the surface area. Back to meters now. So the surface area is 0.5 times 0.2. So that's 0.01 meters squared. So pressure squared. So P is equal to, 1,000 newtons divided by 0.01 meters squared. So that's, add 2 zeros whenever you divide, so that's 100,000 pascals. And in kilopascals, that's 100 kilopascals. So let's go into pneumatics. This little boy created a little pneumatic system. So if you take a cylinder with a liquid sealed inside, it has to be closed and sealed, you can make it do work for you. And if you notice, he's got a small piston hooked up to a large piston, and when he pushes this down, he can multiply his force and push up on there. So Pascal's law helps us understand how hydraulics work. We can magnify the force transferred in a system because liquids are virtually incompressible and the force over the area stays the same if the pressure is constant. So here's our system. The pressure inside this confined space will always stay the same. And so the force over the area on this side will always equal the force over the area on this side. So whatever F over A equals here, it must equal the same over here. So let's disregard the empirical units, and let's use meters squared, and let's use newtons here. So if 20, what's 20 over 2? 20 over 2 is 10. So whatever this is, it has to equal 10. So 200 over 20 equals 10. So if you push with a 20 Newton force here, you'll get a 200 Newton force on this side. Here it is again. So pressure exerted anywhere in a confined incompressible fluid is transmitted equally in all directions, which allows us to F1 A1 will always equal F2 A2. So let's look at this picture. So if we push down here with 1 kilogram on this little piston, we can, if we make a big piston here, we can push up with 1,000 times the force. Let's look at this picture. So the pressure throughout here is 0.3 newtons per centimeter squared. So I can push down with a 3 Newton force here, and I can get a 30 Newton force here. Why is that? Because the force over the area here must always equal the force over the area on this side. So let's check this out. 3 newtons over 10 centimeters squared must equal 30 newtons over 100 centimeters squared. Are these two equal? What's 30 divided by 100? 0.3. What's 3 divided by 10? 0.3. Yeah, they're equal. In fact, they're equal to the pressure inside the fluid. Let's see if we can figure this one out. Here's our hydraulic press. F1 is 2 newtons. We don't know what F2 is. Area 1 is 20 meters squared. Area 2 is 200. How much is F2? Well, let's set up our ratios. 2 newtons, which is F1, over 20 is equal to, I don't know, I'm trying to find out, F2 over 200. So these two fractions have to be equal. So whatever I do to the top, I must do to the bottom, and whatever I do to the bottom, I must do to the top. So what did I do from 20 to get to 200? I had to times it by 10. So I have to times the top by 10 for them to be equal fractions, which means the force 2 over here is 2 times 10, 20 newtons. Let's review pressure again. Sometimes pressure doesn't have to be as tricky. For example, in this question, we know what the mass of the block is. And so we don't need to find the volume. And we know the mass. So if it's 20 kilograms for mass, how much force is that? Okay, well, 20 kilograms equals how much force? Well, we know that 1 kilogram is equal to 10 newtons. So 20 kilograms equals 200 newtons. Okay, so we have the force, 200 newtons. We just need the surface area, and we can find P pressure. Well, surface area has to be in meters squared for it to be equal to pascals, but good, we have meters. So 4 times 2 is 8. So 200 divided by 8 will give us the pressure. Let's talk about pneumatics and how it's different than hydraulics. First of all, instead of a liquid in a confined space, pneumatics uses a gas, usually air. And the thing about air when it's in a confined space is it is compressible. And it'll kind of push back. When you press on it and then you let go, it pushes back. And that principle will help us use pneumatics to do short bursts of work. Jackhammers, for example, basically the piston goes up and then retreats back in a pushing, pumping action. This is a drill that's used by a dentist. So a dentist drill, air comes in and it helps spin a piston. So basically pneumatics is short bursts of work. It's different than hydraulics. Hydraulics uses a liquid. Liquids are incompressible, whereas pneumatics, we have a sealed gas, and gases can be compressed. Our lungs are an example of a pneumatic system. Our diaphragm moves down, and so on. And that concludes our session.